So, how do we make sense of this incredibly complex world around us? I mean, from predicting the weather to guiding self-driving cars, we rely on models. But here's the thing, not all models are created equal. You've basically got two main camps: the meticulous architects who build everything from a known blueprint, and the clever detectives who are all about finding clues in the data. Okay, let's dive into what that really means.
Here's our game plan. We'll kick things off by really understanding the core ideas behind these two kinds of models. Then, we're going to see them in action out in the wild, face their real-world limits, figure out how we even measure success, and finally, discover why their future is, well, it's together. All right, let's get right back to basics. What are the two fundamental ways we even try to predict what's coming next?
This is really the fundamental question that drives all of this. Are we going to use established, rock-solid laws that we already know are true, or are we going to learn from everything that's happened in the past to make an educated guess about what's going to happen next? That choice, right there, defines the entire approach.
First up, let's talk about the architect. Think of it this way. You're building from a perfect blueprint. These deterministic models rely on the fundamental laws of physics and math. We're talking predefined equations where if you plug in the right inputs, you can calculate a super precise output. It's transparent, it's grounded in solid theory, and it kind of assumes a world of certainty. And then, on the flip side, we have the detective. Now, this model doesn't start with a blueprint at all. Instead, it's like a detective sifting through mountains of evidence, tons of data, to find hidden patterns and connections. Using things like AI and machine learning, it figures out how a system works. This approach is fantastic for handling complexity and uncertainty, where honestly no clear blueprint even exists. And this right here, this is where you really see the trade-off. With the architect, you get transparency, you can look inside and see how it works because it's based on known physical laws. With the detective, you get this amazing adaptability by learning from real-world data. So one is kind of rigid but very clear. The other is super flexible but can sometimes feel like a black box.
All right, enough theory. Let's see how these models actually play out in the real world. From the vineyards growing our food to the cars we're all driving. Okay, so first stop, agriculture. Predicting how many grapes a vineyard is going to produce is a massive economic puzzle. And the traditional method, the architect's approach, it's all manual, it takes a ton of work, and frankly, it's often wrong.
But then, you see a number like this, almost 99.6%. A 2023 study showed that a data-driven detective-style AI model could predict vineyard yields with nearly perfect accuracy. I mean, that is a complete game changer, and it's all thanks to the data. So how on earth did they pull that off? Well, the detective model used deep learning to scan 3D images of the vines, precisely identifying and counting every grape cluster. Then, machine learning took all that information to calculate the final yield. It's just a powerful example of how these data-driven methods can shine where the old-school deterministic ones just struggle. Now, let's shift gears, literally, and head to the automotive world. Controlling a car's speed in traffic is incredibly complex. You've got endless variables, right? An architect's rigid, rule-based model just has a really tough time keeping up with that chaos. So the solution is a more intelligent form of control. Researchers tested these data-driven intelligent controllers against the traditional ones, and the results were just crystal clear. The detective-style models were way better at adapting to changing traffic, handling all the uncertainty and the messiness of the real road with ease.
Okay, but here's the thing. It's not like the detective is a silver bullet that solves everything. Every single model, whether it's an architect or a detective, has an Achilles heel. And this is the reality check. The challenges are pretty clear on both sides. The architect, it struggles with noisy measurements, and it's just too rigid for situations that are constantly changing. The detective, meanwhile, can get way too fixated on the specific data it was trained on. That's a problem we call overfitting, and it can be really hard to understand why it made a certain decision. Oh, and it needs a ton of high-quality data to even work.
Now, in a field like healthcare, these challenges have life or death consequences. Predicting cancer demands incredible precision, and if you rely on just one type of model, you might fall short. So what happens when we make them work together? And this chart, wow, it just tells such a powerful story. A 2024 study found that standalone machine learning and deep learning models, they were already impressively accurate. But When they were combined into a hybrid digital twin, which is basically a virtual copy of the system that learns from real-time data, the accuracy shot up to a staggering 99.73%. That right there is the power of teamwork.
This brings up a really important question. How do we even define success? Because a single accuracy number, as impressive as it might be, doesn't always tell you the whole story. We've got to measure what truly matters. You know, success just looks totally different depending on what you're doing. For a self-driving car, it's all about split-second response time. For cybersecurity, it's this delicate balance of catching threats without flagging innocent activity. For those vineyards we talked about, it might be about pixel accuracy. The right yardstick depends entirely on the job you're trying to do. And to really do a proper evaluation, you have to go even deeper. You have to ask, how robust is this model? How does it handle a curveball? How sensitive is it to tiny changes in the input? In really complex fields, like AI for video games, they even evaluate things like logical consistency and creative support. It's about so much more than just a single number. Okay, so this all brings us to our final and, honestly, our most important point. After seeing the strengths and the weaknesses of both the architect and the detective, the path forward starts to become really, really clear. So, at the end of the day, the big takeaway is this. It's not architect versus detective. It's not about choosing one over the other. The future isn't just the architect, and it isn't just the detective. It's both of them, working together. The future is hybrid. And here's the beauty of how it works. You start with the architect's deterministic model. That gives you a strong, reliable foundation grounded in physical laws. Then you feed it real-time data to constantly refine it and correct for what's actually happening. And finally, you layer the detective's AI on top, and it learns from all that data, adapting to all the real-world messiness the original blueprint could never have predicted. And this quote just nails it. You get the best of both worlds. You get the theoretical grounding and the transparency of the architect, and you combine it with the adaptability and the real-world accuracy of the detective. That synergy, that is what gets you the best possible results. So, as we wrap this up, I want to leave you with a question to chew on. Think about the massive, complex challenges we're facing, from climate change to personalized medicine. Which of those huge problems could be tackled by combining a solid scientific blueprint with a smart, real-time, data-driven investigation? The possibilities are, well, they're truly fascinating to think about.